Hi everyone, very good morning. My name is Sharath and I'm a lead AI vision engineer here at IITEX. So before before I start my presentation, I just want to give a brief demo of of our platform. So let's see the demo. So it's our own platform which is built for solar AI industry. So like how can you integrate AI into solar industry? So we have our own dashboard, which is like we equipped with our own drones with two kind of CC cameras. One is the thermal imaging and also with the AI RGB imaging. So we have two use cases for these. So the first one is to find the diode failures and all the electrical failures in the AI form, and the second application is the what's the soiling level on the solar panel. So yeah, as this expo is all about the solar industry, so that's why we are focused on the solar industry. But we are also we also have our wings across like different industries, just such as banks and also data centers. So especially we are focusing on the solar industry. That's why this slide is all about the solar industry and what is our use cases and what is the real time problem which we solve. So the first one. Yeah, so we have our own platform. Next slide. Yeah, so our mission is to have the optimal output from the solar industry, because like we have like so let's say if you have 100 acres or 200 acres of solar industries, and like no one can go each and every panel to see what's the electrical failures and everything, right? So like instead of that, we use our own drone systems. So our drone will fly across like 100 or 200 acres of the industry, and then we take the inputs from the drone and we do the image processing, and like mostly we use the AI model stuff. So like I lead the AI division here. So from the image processing, we Yeah. So from the image processing, we actually take the electrical failures and give a detailed report within 24 hours. So like we are associated with the three of the main clients all over the India. So in the northern part of India, the central and the southern part of India. So we know what is the climate structure, and like what is like at what time we have to fly the drone, and how efficiently we can give the AI models. We have like three flavors in our models. So it depends upon the regions which we are associated with, and we have like, so we segregated this into three infrastructures. So the first one is the intelligent hardware layer. So we have our own hardware. We also have our own drones which is equipped with AI and vision capabilities. So firstly we fly this drone across like 100 acres and then we take the imagery and do the image processing on that, which is like very efficient. Within like you get the output within 24 hours to maximum 44 hours with also the report, and you have the detailed reports of what is the row table number and everything, what is needed in the report. And the second one is the AI model layer. So we do everything from the scratch. So we built our own model architecture. We built like everything from the scratch. We also have our own cloud service provider, and all data is equipped with also the hyper parameters of the data, and then we superimpose on the RGB images. So and the third one is a cloud infrastructure. So we are associated with the GCP, and also we are associated with AWS for our cloud services. Yeah. So this is like so. Let's say if you have solar industry and you wanna map exactly what electrical failure are inside the solar panel, right? So we actually take orthogonal image of like we take a small snapshots of every frame by frame of the whole plant, and we have a 3D imagery of the whole plant, and then we superimpose what are the errors which we found using our AI model, and then remap to the RGB images. So it will be very interactive to the end customer. So like he can go exactly to the latitude, longitude, and also what is the location which we specified, and he can rectify this error within a day or so, because it actually depends upon like firstly we evaluate our things like we need the basic details like how is the plant structured. We also need the infrastructure of the plant, and then we evaluate our model. So we have like as I said, we have like different flavors in the model, right? So depending on the use case and what is the severity level, and what is the like how much till how many years it has been actively performed and what's the efficiency of the plant. So depending on that, we have our own infrastructure. Yeah, so now at the moment we are also into construction of the solar farm. So till then we are an end-to-end like AI solution architects. So like initially you have a land and you want to have what is the progress of the last year and this year, and you have a real-time monitoring system of like what is the progress from the last year and how many installations has been defined from the last year to the present running year. So you have a live monitoring system, and yeah, so let's say about like you have we are equipped with two cameras, as I said. One is the RGB and the thermal imagery. So using thermal imagery, we are segregated into three different kind of structures. One is the hotspot, diode failure, and the string reverse polarity. So depending on like how many years the solar plant has been in the industry, so we evaluate on that. So the most common cases are the hotspot and diode failures. The hotspot you can neglect for like almost like a bit 2 or 3 weeks, but for the solar for the failure of the diode, it should be very intense. You should replace the cell, otherwise the whole module will get destroyed. So that is why we have our own AI applications for this. Yeah, so let's say you have a map, so you have your and some n number of acres of land, and then you want to and this map is not defined in the maps architecture, so we also define that. So like we take imagery of the drone and then we superimpose on the API call from Google, and then you have a visual map of your own farm. Otherwise, like some of the farms which are not defined on the maps, right? So to solve this issue, we also give the end-to-end solution for this. So like in our own dashboard, you have a 3D architecture of a map of your how many rows are there, like what are the use cases and what are the electrical failures, and then depending on that, you have your solution. Yeah. So this is. Yeah, so we also give a detailed report of what is the health of the solar plant. So depending on this, on the electrical failures and what is the soiling level, we evaluate our model. Like if you have like n number of electrical failures, we give a detailed report on that. And how also like after you have the report, we also give the maintenance strategy, like how efficiently you have to keep monitoring your plant, and like how oftenly you have to clean your plant. Yeah. So then this slide is about the forecasting. So like some of our customers are facing like at what time we have cloud at this time. So we also give like at what time you will be having the cloud and at what percentage you have to decrease the efficiency of the plant, because like if you have clouds, the efficiency would be decreased to 20 to 30% depending on the rain and the clouds. So we install our own CC cameras so that it will be have a continuous monitoring system. So like it is also equipped with the weather forecasting, like at what time you have your rain and what time you have the clouds, and so depending on that we give the instructions to the plant so that you have to decrease the amount of efficiency. Like so this is the rate which you'll be affecting later. Yeah, so this is the example of the 3D visualization which we built for our recent clients. Yeah, so the other use case is about the animal detection. So because like we are spread across like 3 different like hemispheres of India, right? So like some of the clients are also facing animal issues, like let's say you have a like bird drop on the solar industry, right, on the plant. So we also rectify that using the RGB images. We continuously monitor using our own CC cameras, and like and we fly the drones per once a month, and depending on your needs. So we have a continuous monitoring system so that if you have any physical damages of the solar plant or the bird drop or any other like damages in the plant, so we actually have the real-time system. Okay, this panel is having this electrical issue, this is having a physical damage, or you have to clean this panel. Exactly. So And yeah, we are also into different industries. So this is all about the solar. That's why we are mostly focusing on the solar. But we are actually spread across our wings across the banking industry, and also with the data centers, and also with the construction business. So we right now have a different use case, different clients. So depending on their client requirements, we define our own hyperparameters, our own AI models to have this. And yeah, so we are into like as explained to you, we are into like a different kind of application, and we are actually wanted to spread across other industries, which I'm really interested to have this on stage. And yeah, so at the moment, these are our valuable customers. So we recently got associated with all of these industries, and we are doing a fantastic job here. And the efficiency of our model is about 92%, which is like which we like. So as a AI model, we have to keep on training, and the efficiency will be like much more higher when you from the last model. So I guess by end of this year, we gonna reach about 97% of the accuracy, and we'll be reaching out to other industries. Thank you from Inside Eye.